We are still doing past exam questions, but this time we are focusing on longitudinal waves. Let's go ahead and take a look. A longitudinal wave is a wave in which the particles of the medium move parallel to the propagation of the wave. The particles move parallel. In a transverse, they move perpendicular. Right, so that is longitudinal wave. The second question, name the paths labeled R and S. So let's go ahead and take a look at what's happening. A tuning fork with a frequency of 100 Hz created a sound wave as illustrated below. Here is our part R and here is our part S. Part R is a region of high pressure. A region of high pressure in a longitudinal wave, we call that a compression. So R is a compression, it's a region of high pressure. Taking a look at part S is a region of low pressure, and in a longitudinal wave we call that a rarefaction. So we have a rarefaction for part S. So there we go. Part R, compression. Part S, rarefaction. Let's carry on. Calculate the period of the wave produced. We have the frequency, so calculating the period should be an easy task. 1 divided by 100. This should be equals to 0.01 seconds. So there we go. The time taken to complete one wave is 0.01 seconds. The period. The second part of the question, quite interesting. A group of scientists on a submarine want to locate a whale. A signal generator on the submarine sends a wave signal underwater, and it is detected 3 seconds after being reflected by the whale. Obviously, the speed of sound in water is 1,450 meters per second. The question says, let's calculate how far the whale is from the submarine in kilometers. How far? We are interested in the distance. What information do we have? We have the speed of sound in water, V, which is said to be equals to 1,450 meters per second. Obviously, we need the time to say that the distance is equals to speed multiplied by time and calculate how far the whale is from the submarine. It takes 3 seconds for the waves to move from the submarine, strike the whale, and get reflected back to the submarine. But we want the distance between the submarine and the whale, so we need to take half that time. So delta T will be equals to 3 divided by 2. This is a situation that is very close to echoes. If you still remember, we did a few examples on echoes where we have to divide the time by 2, and this is one of those examples. So the distance is equals to the velocity multiplied by the time, or the speed. Let me not say velocity. So in place of speed, we have 1,450. That is the speed of sound in water. Water is denser than air, so the speed should be more than that in air. So 1,450 multiplied by 3 divided by 2. This is equals to 2,175 meters. And there we go. Hold on. The question says in kilometers, not in meters. So we actually have to divide this distance by 1,000 in order to convert the meters to kilometers. So let's go ahead and do that. The distance will be equals to 2,175 divided by 1,000. And then our answer, rounded off to 2 decimal places, will be 2.18 kilometers.